Hi, good afternoon, and welcome to the third of 3 sessions on introducing XPath, where Christopher's going to show us a bunch of examples of XPaths and axes and visualize a quiz on how they work. Go ahead, Christopher.
Thanks, Gabby. Right, so let's do some practice. Let's look at some XML trees and let's figure out how to navigate our way around these trees, because that's really the essence of working with XPath. So here I've got an extremely simplified schematic of the Bad Hamlet tree, or the Bad Hamlet file that we're giving you in this class. And it's fairly simplified because I just want to illustrate this for visualization purposes, that here's your root element. And I'm going to be showing this tree left to right rather than top to bottom, because I feel like it works, at least with my brain, a little better that way. So the root element here on the left is the TEI element. That contains 2 elements, TEI header and a text element. Text element contains a front element and a body element. Body contains a div. The div contains another div, which has a sibling head element. And each div of each act text has another head element, stage element, SP element. SP element, speech element, contains a speaker element and an L element. So we'll be navigating through these examples by rendering this sort of schematic as we go. But another thing you can do is visualize in Oxygen the outline of any XML file. And here you can also see how all of the elements are nested using those arrow buttons. You can kind of figure out how elements nest and what kind of tree structure might look like from an outline point of view. Now, going back to our schematic, I just want to run through some examples to get us navigating through this tree. So here we have an absolute path that says start at the beginning, so TEI root element, and then a path step, single slash, to the text element. Within that, take another step into the body element, and then the div, and then the head. So the way we're traveling is TEI to text, to body, to div, and to head. Similarly, if we were to add another path step to go into another div and then into another head, so in other words, a nested div within another div that contains a head, you're bypassing this head here and going into the head of the second level div. So the div nested within the div. Now in this example, we've got the relative path double slash div. And what that does is it takes us to any div, regardless of where it is in the tree. So again, if you want a really generous search through your TEI document, the double slash is the best way to go. Similarly, if we add a predicate, which filters the results, so in this case, double slash SP or speech is filtered with the who attribute. Here we're just getting all the SP elements. And by doing that, we can also add additional predicates, such as find me the first line nested within each speech. That's what this square bracket 1 indicates. And going back to the who attribute, you can also indicate the value of a specific who attribute within each SP. So here we've traveled into the SP with the Laertes 2 attribute value. And obviously that means we are not getting the SP who attribute value of Hamlet. So this is just a fine-grained way of searching through SP elements using filtering or predicates. Now, going back to axes, let's say we want to find all head elements that have ancestor divs. In other words, what head elements have div as ancestors. And in this case, you can see in these red circles, this head has a div ancestor, and this head also has a div ancestor here on the left. Similarly, we can, for example, look for any div that has a div as a descendant. And that gives us the result here of this first level div. And the reason why we're getting this result is that we are looking for a div that has descendant divs. That's what the predicate is filtering for us. And this might not be the most useful example in practice, but it gives you a sense of where a context node is, this div right here, and how it relates to its descendants, which is beneath it, as it were. And then let's consider something like the following axis, which allows you to identify which speech elements have a following elements within it. So the reason why we only get this first speech element here, as opposed to getting this one too, is that this speech element has a following speech element. This one doesn't. So this one is saying find any speech element that has a following element of any kind, including its context node, including itself, in other words.
The reason, just to
Yep.
to labour that point, the reason the second speech is not called by this XPath is that once the second speech closes, all the other elements in this file are inside that speech. Once that second speech closes, the only thing that's left to happen is the div closes, its containing div closes, the body closes, the text closes, and the TI element closes, and then no new elements open again after that speech. So it has no following elements. Therefore, it is not caught by this XPath.
Yes. Yeah. Thanks for that. Yeah, it's harder to explain with these simplified graphics, but that's indeed the point here, why we're only getting this result instead of this result as well. So let's have a look at this one. So in this case, we're looking at all speech elements that have child L elements and count them. So what does that look like? It looks like counting the speech elements that have these child L elements. And the result is 686 if you try that in your XPath search in Oxygen.
Although, just to point out, if you did that search on this XML file represented by your visualization, the answer would be 2.
Yes, that's right. Yes. Yes, I am plugging these XPath expressions into the bad Hamlet file in Oxygen when I'm getting this number. But you're right, it would only be 2 in this case. Right, so let's have a quiz to see how well you've understood XPath so far. And we'll have much more time to practice this together, but this should give you something to think about. So after I ask these questions, it might be good for you to pause the video and take a moment to think about what the answer might be before I switch to the next slide. So here, what's the difference between the / stage expression and the / stage expression with a 1 in square brackets, in other words, with a predicate of 1? Well, if you go into Oxygen and plug in / stage, have a look at what the results are showing you. This is giving you stage elements anywhere in the document. And notice here, you have a stage element followed by another stage element. And what that means is you're getting stage, the first occurrence of stage, followed by a second occurrence of stage, or a sibling stage. And you can see that in this XPath location here for the second stage element. See how it says stage square bracket 1 and then stage square bracket 2. So in this case, we're finding all these stages because it's a very generous relative XPath expression. Now, if I put in 1 square bracket 1, then I'm only getting the first occurrence of stage. I'm not getting the second occurrence like I showed in the previous slide. So in other words, the double slash stage finds all the stage elements in the tree, whereas the /stage with a 1 predicate finds only the first occurrences of any stage element in the tree, and that gives you a difference of 264 versus 218 results. So in other words, there are almost 50, about roughly, instances where you get multiple stages in one speech. Okay, so what's the difference between these two? /stage with a parent L, or /stage followed by any line that is a parent. Right, so the first one tells you to find all stage elements that have L elements as parents, and that's highlighted here below. Whereas the second one is to find all L elements which are parents of stage elements. Now the crucial thing is the path step versus the predicate. So here we have a predicate that says filter all the stage results by parent Ls. So we only want parent Ls of stages, right? In this case, we've got a path step. So it says find all Ls that are parents of the stage elements. And you can see in the highlighted results here how that differs. Okay, so then what's the difference between these two expressions? /stage parent div versus /stage / parent div. Quite similar to the previous example. Take a moment to think about that. So the first one finds all stage elements which have a div as a parent. So again, that filtering mechanism of the predicate is used to find only stages that have a certain type of value, namely a parent div, or a div as a parent, sorry. Whereas the second one is find all divs which are parents of stages. Okay, now what does...
I guess one thing that might help people to sort of understand a little bit more that previous example is that although in both cases you're finding a div containing a stage, right? The difference is what is the context after you found it. Yeah, and in the first instance, the context is the stage, because the stage is the last thing in that line that has a slash before it. And in the second case, the context is the div, because that's right. Is the last thing that has a slash before it.
Yeah, that's a good point. It's always important to be aware of what the context node is when you're doing these tests. And as I said a moment ago too, it's the crucial difference has to do with the path step, right? Like whether you're indicating a search from a path step versus a predicate. That changes the context node basically, even though they look similar as expressions. Okay. So last, not last, but what does this instruction below do? This one's a bit tricky, but try to interpret it from left to right as best as you can. So what this means is find each second occurrence of a second level div. In other words, in Bad Hamlet, you're looking for each second scene of each act. So nested div within the first div, the second nested div within the first div, and return the last lines of speeches that have a string length greater than 500 characters. That's what the last here is doing. So in other words, we're doing a kind of combination of predicates and path steps and functions. So the / says take me to any div, and then the path step says now take me to each second div within each first level div, and that's why we're getting the second scene of each act, because that's the second div within each first level div, and then travel into this speech element. Within that go into the L elements, and then the predicate last with open parens says find the last L, only the last line, and then a separate function that says give me, return the string length, return those last lines that have a string length greater than 500.
May I paraphrase that, Christopher? In a slightly more pedantic way. When I'm trying to read an XPath left to right, I read a slash as being and then,
right,
and a square bracket as being but only. Right? So
okay. Yeah.
Reading left to right, find me any div in the document, and then its child div, but only the second one. And
right.
Then its child SP, and then its child L, but only the last one, but only if the string length is longer than 500.
Yeah, that's a good way of putting it. Yeah, with predicates, we're trying to only return certain kinds of results, and sometimes you need that kind of specific information, especially if, in this case, you've got nested divs, and it's important for you to be able to only grab things like the last lines or the second, scene of each act or something like that. And that's the but only bit. Okay, so let's look at a similar expression then, but different. Consider how this is different. Now, what's happening here? Right, so in a way, you're searching pretty similarly to the previous example, except instead of grabbing the last line within each second div within the first div, you're grabbing the first line. So the predicate one is just grabbing the first line instead of the last line. And just to make things a little tricky, I changed the string length to be greater than 200. So in other words, find each second occurrence of a second level div and list the first lines of speeches that a string length is greater than 200. So it's really the only difference, other than the string length being greater than 200, is finding the first line in a predicate versus the last. Last question. And it's similar to the previous slide in a way, but have a think about what this instruction is doing. Most of it should look fairly familiar to you, but what's different and how is it different? So in this case, we're looking at each second occurrence of a second level div, so each second scene of each act, as before, except in this case, you're only returning the last instance of a line in each speech that has a string length greater than 100. So how is that different from the last one? Go back here. So each of the last lines of speeches here are being returned. And then here you're only getting the last instance of a line with string length greater 100. So much fewer results, in other words. And if you want to test these things out, it's always helpful to copy and paste these expressions into your XPath tool in Oxygen and to see what the differences really are, because a lot of times you start to learn this by plugging these things into Oxygen and testing them out. And it's often the best way to kind of get your way around these concepts and navigating through these axes and predicates and so on. We'll have more exercises in our Zoom session to experiment more with some of these kinds of of XPath expressions. But for now, I'll just leave you with a link to David Birnbaum's really excellent page on XPath, which has a lot more information and a lot more detail. And so it's very good further reading to engage in if you're interested in XPath. So that's it for this one. Thanks, Gabby, for being a helpful translator to an otherwise naughty language. Do you have anything that you want to add or any questions?
No, only that I only sort of interjected because these are so tricky to understand. Sometimes it helps just to get two different perspectives on the same thing.
Yeah, no, it's true. And also, I mean, we were talking about this while we were prepping, but it's also important to emphasize that a lot of these expressions that we've shown you could be written differently and you would get the same result. So a lot of those axis expressions, for example, can be written in a simpler way with a relative path expression. Sometimes predicate expressions return something that you could get the same results with a different expression. So it's not a kind of unforgiving language in a way.
Yeah, and I guess it largely comes down to personal preference whether this XPath I just put on the screen, head with an ancestor div, is preferable to //div//head, which both mean exactly the same thing.
Yeah, that's right.
Head with an ancestor div, any div, and then any descendant head. I think that they're basically the same thing. I mean, they may enable you to do other things if they're building blocks of a more complex thing, but in both cases the context is the same. The context in this case is the head, and in this case the context is the head. But one may be easier for you to visualize than the other, and it comes down to personal preference a little bit when you're writing your XPaths.
Yeah, that's a good point. And that's, if you get the right answer, you get the right answer either way, and that's the important thing.
Yeah.
But yeah, some people have certain preferences about how to express their XPath. So. But we'll practice more and talk more about this during our Zoom session.
Cheers, thanks, Christopher.
Thanks.